One of the more common use cases for Docker is running long-lived web applications. In this chapter, we'll launch a simple web application that interfaces with a key value store and displays a web page. For our data store, we're going to use the popular key value store Redis. Redis is extremely simple to run in Docker. The name of the official Redis image is simply Redis. Let's launch one in the background with the name Redis. Our database is now running. The next thing we need to do is start our web application. The web application needs to be able to connect to Redis to store and retrieve data. The container we'll use for our web application is called O'Reilly Simple Web App. In a couple minutes, we'll start up the web application and link it to our database. We can connect our Simple Web App container to the Redis container using Docker links. Docker links allow containers to find each other by IP and port. Docker containers are linked by name, and Docker injects a set of environment variables into the container that can be used to connect them. For example, we can link an Ubuntu container to our Redis container with the link flag. This will set a number of environment variables telling our container where the Redis container is. Let's try it out with an interactive shell. Now that we're inside the container, we can run env to inspect the environment variables available. Notice this environment variable, Redis port 6379 TCP address. This gives us the IP address of our Redis container. This environment variable uses the convention name, port, and then the port that's being exposed, TCP address. So this means we have to know the name of the container and the port that we want to connect to. Our simple web application is written to use this environment variable to connect to Redis and retrieve and store data. So let's run our simple web application and link it to Redis. Notice here, we've added the link flag with the value Redis to our run command. One thing to mention about Docker links is that they're deprecated and will be removed in a later version of Docker. We will discuss the newer preferred mechanism for networking containers in a later chapter. Our web application is started, so let's open a browser and try hitting the web page which is served up at the root. Oops, that didn't work. We know the reason is that even though the application inside the container is bound to port 4567, we cannot access it on the Docker host without mapping the port. We can do that with the lowercase p flag. The p flag takes two delimited port numbers. The first port is the port on the Docker host to use, and the second is the container port to map. So let's map 456 inside the container to 456 on our Docker host, and try again. Okay, we've restarted the web application with the ports mapped. Let's try one more time. And there we go, we can now see the web page. You can see that the message on the page says, the data in the Redis database is, and then it's blank. Our web application has another endpoint, which allows us to load data. The endpoint is /load, and the path parameter is the data to load. So the data that we're going to load into Redis is simply the word hello. Our data is now loaded into the Redis key value store. Now when we refresh our web page, we'll see the word hello, which is the data we've loaded. And there we have it. What if we're deploying web applications on a machine and we don't know what ports are available? In a lot of cases, we can't be guaranteed a well-known port for every application. Docker offers the capital P flag for this very scenario. The capital P flag binds all exposed ports inside the container to a random available port on the Docker host. So now that we've used the capital P flag, how can we find the port that the application was mapped to? One way is to use ps-l, which lists the last run container only. There's our port, 32,773. Another handy way we can find the mapped port is by using the docker port command, which simply tells us the port the application is available at on the Docker host. Once again, there's our port. The capital P flag is very handy for applications that run in a dynamic multi-tenant environment. Later in the course, we'll build our own application image and illustrate how we can expose ports. We'll also show how to create custom bridge networks that allow a cluster of Docker applications to communicate directly, without the use of deprecated Docker links.